Okay, so this is the Chapter 17 practice quiz review. According to Gallup, about 33% of Americans polled said they frequently experience stress in their daily lives. Suppose you were in a class of 45 students. So thinking right now, our N equals 45. Okay, I'm thinking my N value is going to be 45. My P value is going to be 33%, which is 0.33. And so if my P is 33, that means my Q is going to be 0.67 because 1 minus 0.33 is 0.67. So let's continue. What is the probability that no more than 12 students in the class will say that they frequently experience stress in their daily lives? So it says no more, so I'm thinking like a less than problem, less than or equal than. And 12 students out of 45. So 12 out of 45 is 0.267. So about 26, almost 27%. That's my p hat because that's what I'm going to observe in my classroom. So in my classroom out of 45 students, I observe no more than 12. So make sure to identify the sampling distribution you use and check the necessary conditions. Let's go through the conditions. The first condition, is it random? It doesn't really say, so we're just going to kind of make the assumption the 45 students in the class are just kind of randomly selected, but that's not necessarily the case, so we're just going to go ahead and kind of just assume that it's met. Okay, all students, I guess, randomly can experience the stress. It's not like it's like we're at a location where stress is like why we're all there for 45 students, right? Okay. 10%. Does it pass the 10% rule? Is 45 students less than 10% or less than 10% of all, assuming the American high school students? Yes. And are we going to have at least 10 successes, 10 failures? Yes, because we have 33% of 45. Plugging that in. We're expecting an average of 33%. So about 14 or 15 students. And about 30 students did not meet that requirement. So we are meeting our requirements of at least 10, so all three conditions are met. Okay, so let's go back and let's see here. We have our sample size of 45. We have 33. We're expecting 33% to frequently experience stress, 67 to not frequently experience stress, and we're trying to see if we can observe 12 or less students or less than 26.5 or 26.7% students that experience the stress. So we're going to find the standard deviation by doing the sigma equals the square root of our p times q divided by n, and that gives us 0.07, all right, 7%. So I went ahead and plugged it into the calculator, the normal CDF. Okay, that was slide on. That's here above variables. That's from the distribution menu. Okay, so I'm going to go there. This is a normal function or a normal distribution problem. So normal. The lower is 0, okay, because this is less than our 26.7%. So less than that, the lowest it goes is 0. The upper is that 0.267. Our mean is 33. And the sigma we've calculated to be 0.07. Calculating that, we get 0.184. Okay, so 0.184, which gives us about 18.4%. So 1A, here we go. Probability that there'll be no more than 12 students in class out of 45 that experience stress in their daily lives. About 18.4% chance. Part B, if 20 students in the class said they frequently experience stress in their daily lives, would you be surprised? Explain and use statistics to support your answer. So 20 students, so 20 out of 45. So what if I observe 20 out of 45? That's about 44%. okay, of my class. So my z-score for that 44% would be 44.4% minus the 33% divided by that 7% gives me 1.63. Okay, so a z-score of 1.63. We're going to use 2 and negative 2 as our boundary for stuff unusual. Anything between negative 2 and 2 is going to be usual. So I would not be surprised because 20 students is only 1.63 standard deviations from the mean of students I would expect. So I would expect, right, 33%, but 44.4% of my students having stress every day. It's not perfectly average. It's above average, but it's not so far above that it's unusual. Okay, if that number was 2 or above, that would now be unusual. 1.63 is not unusual. Okay, so explain using statistics to support your answer. That's using statistics to support our answer. Okay, I'm going to move this. The average composite ACT score for Ohio students who took the test in 2003 was 21.4. Assume that the standard deviation is 1.05 and a random sample of 25 students who took the exam in 2003. What is the probability that the average composite ACT score is 22 or more? Make sure to identify the sampling distribution you use and check all necessary conditions. This one has something a little bit different than we've done in the past, and that's to find the standard deviation of a sample, just given what we were given. Okay, it's kind of tough because we have the SAT score and not like the percent they got correct. So here we go. Sample size, 25 students. Our average score was 21.4. You can't really do like a Q with this right now because it's kind of that's just the average score. The observed score was 22. Okay, well, it's 22 or more. And the sigma they gave us was 105. Okay, so this sigma is over the whole entire, all the Ohio students. We want to figure out the sigma or the standard deviation for the sample. We need that for our problem. So to figure out the sigma for our problem, standard deviation for our sample, we have to look at the standard deviation equals 1.05, which is the population standard deviation. Divide that by the square root of the sample size, 25, and that gives us 0.21. I believe we did this in Unit 3, Chapter 16, or Chapter 15. There's a formula that says standard deviation of a sample is sigma divided by the square root of your sample size. So the standard deviation of a sample, where sigma is the standard deviation of your population, okay, that you're looking at. So when I get that new standard deviation of 0.21, I'm going to plug that in to get my z-score. Okay, z-score is the observed value minus the population average, right? The 21.4. Divide that by the standard deviation here we found of our sample, 0.21, and that gives us a z-score of 2.86. Okay, 2.86. So I got to find the probability of getting a z-score of 2.86 or greater. So this one gets a little bit tricky the way I'm going to solve this. Let's see here. It says our x value, probability of x being greater than or equal to 22. Okay, scoring a 22 equals the probability of getting a z-score of greater than or equal to 2.86. Okay, and that now is going to give us an answer of 0.0021. So there's two ways to do this, and I'm going to fill this in with you guys. Take a look here. We've got a z-score of 2.86. On your chart, okay, 2.86, so there's 2.8, 2.80, 2.8, 2, 3, 4, 5, 6 is 0.9979. 0.9979. That's the left side. That's less than. We don't want less than. We want greater than. So if we simply just take 1 minus that 0.9979, we would get 0.0021. On a calculator, okay, on a calculator, if we go to our distribution and we scroll down until we get to normal CDF, okay, our lower, since it's greater than, our lower, we're going to use a z-score of 2.86. Okay, so we haven't really done one like this. We're talking about lower and upper limits for our z-score. So z-scores can go on to basically infinity, okay? Z-scores just tell you how far it is from the mean. So for a z-score, my upper, I'm just going to use a number like 5, because a z-score of 5 is pretty big dealing with normal distribution. Okay, anything beyond 3 is really unusual and unique. I'm just going to throw a number like 5. You can throw any number you want. You should get similar results. Remember, we already have the answer. We know the answer by using the table at 0.0021. I'm showing you how to use a calculator. So the average z-score is 0 with a standard deviation of, I believe we're going to use 1 here. Okay, let's paste it. Let's hit enter. And I get 0.0021, which is the same result we got from the table. So one more time, going back to this problem, if I change this upper number to like a big number, we should see the same exact result. Okay. If I make it a number like 3, where it's just a little bit bigger, it might kind of skew our results. You notice it's going to be a little bit different. Okay. So I would use a number like, let's see what 4 does. So 4 is right there, but I would say let's just use 5 or 10, something like that as a general easy number to remember. Okay. All right. So thank you very much for watching. Let me fill in what did I do. My normal CDF, the first number was, since it's greater than, it was 2.86. The max I went to for this case originally was 5. We'll do that. The average standard deviation is 0. And I used the average z-score was 0, right? And for standard deviation, I just used 1. So I used that. This was my result. Okay. Make sure to identify the distribution you use in total state conditions. We have 25 people. I'm pretty sure we have 10 that meet the percent in that vote. Less than 10, 25 is less than 10% of the kids. And was it chosen at random? Yeah, it says it's a random sample. So I feel pretty confident with those numbers. So all conditions were met. Okay. Hope you got a lot out of this video. Make sure you're practicing for your quiz.